The future of war isn't just land, sea, or air. The new battlegrounds are being drawn in the digital ether, the vacuum of space, and the autonomous logic of machines. Today, we conduct a detailed comparison of the United States and China to determine who holds the more advanced military technology in 2025. This isn't a question of sheer numbers, but of technological supremacy, where a single innovation can shift the global balance of power. The domains of conflict are expanding, and with them, the complexity of modern warfare. In the skies, stealth remains a cornerstone of air dominance. The United States maintains a significant lead, built on decades of operational experience with platforms like the F-22 Raptor and the globally deployed F-35 Lightning II. This fifth-generation fleet is defined by its low observable characteristics, advanced sensor fusion, and networked warfare capabilities. Furthermore, the U.S. is already looking to the next generation with the B-21 Raider, a long-range stealth bomber designed to penetrate the most sophisticated air defenses on the planet. However, China's aerospace industry is proving to be a formidable competitor. Its J-20 Mighty Dragon stealth fighter fleet is growing at an impressive rate, with continuous upgrades to its engines and avionics. While it may not yet match the all-aspect stealth of its American counterparts, the J-20 represents a credible threat, rapidly closing the technological gap and challenging U.S. air superiority in the Pacific. Perhaps the most urgent area of competition is in hypersonic strike capability. Here, China has established a clear, if temporary, advantage. It has already fielded operational weapons like the DF-17, a hypersonic glide vehicle capable of maneuvering at extreme speeds within the atmosphere, making it exceptionally difficult for current missile defense systems to intercept. This gives Beijing a powerful anti-access, area denial tool. The United States, after initially deprioritizing hypersonics, is now in a full sprint catch-up mode. Multiple programs, such as the Air Force's Hypersonic Attack Cruise Missile, or HACM, and the Army's long-range hypersonic weapon are undergoing aggressive testing. While the U.S. has faced some developmental setbacks, its vast research and development infrastructure is now fully engaged. The critical question is not just about speed, but about the guidance systems, terminal maneuverability, and the sensor-to-shooter chain required to make these weapons effective in a contested environment. The drone wars showcase a fascinating strategic divergence. The U.S. leads in high-end, persistent unmanned systems. Aircraft like the MQ-9 Reaper and the RQ-4 Global Hawk offer unparalleled intelligence, surveillance, and strike capabilities over vast distances, backed by decades of operational refinement. The secretive X-37B spaceplane further represents the pinnacle of reusable autonomous systems. China, while developing its own sophisticated platforms like the high-altitude WZ-8 reconnaissance drone, has focused heavily on a different philosophy: mass. Chinese industry excels at the rapid, low-cost mass production of a wide variety of drones. Their strategic doctrine increasingly emphasizes the use of coordinated drone swarms, designed to overwhelm an adversary's defenses through sheer numbers and networked, autonomous attacks. This creates a classic quality versus quantity dilemma for military planners. In the invisible domains of cyber warfare and artificial intelligence, China and the U.S. are locked in the tightest race of all. Both nations possess sophisticated cyber espionage and offensive cyber capabilities, capable of disrupting critical infrastructure, military networks, and communication systems. The true battleground, however, is shifting towards AI. China has made AI a national priority, leveraging its vast data resources and state-directed research to develop AI for applications ranging from autonomous vehicles to predictive intelligence analysis. The U.S. military, through initiatives like Project Maven, is also integrating AI to process intelligence data at machine speed. This race is not just about better algorithms, it's about trust, ethics, and the terrifying prospect of AI-driven autonomous weapon systems. The challenge for both is creating safeguards to prevent unintended escalation in a conflict where decisions are made in microseconds. For decades, space has been the ultimate high ground, and the U.S. has been its undisputed leader. The Global Positioning System, or GPS, underpins nearly all modern military operations, from guiding munitions to navigating fleets. Advanced military communication satellites and unparalleled space-based intelligence assets give the U.S. a significant strategic advantage. But this leadership is being challenged as never before. China is expanding its space capabilities faster than any nation on Earth. It has built its own independent satellite navigation system, Beidou, and its Tiangong space station is now permanently crewed. More critically, China is developing a suite of counter-space weapons, including ground-based anti-satellite missiles, co-orbital robotic arms, and directed energy weapons, all designed to deny the U.S. its critical space-based advantages in a future conflict. On the high seas, the story is one of numbers versus technological superiority. By pure hull count, China now has the world's largest navy. Its shipbuilding industry is a marvel of industrial might, churning out advanced Type 055 destroyers and new aircraft carriers at a pace unseen since World War II. However, the U.S. Navy still holds a decisive technological edge, particularly in its carrier strike groups, which represent unmatched power projection capability. The most significant American advantage lies beneath the waves. The U.S. submarine fleet, composed of hyper-advanced Virginia-class attack submarines and Ohio-class ballistic missile submarines, is quieter, more capable, and possesses a level of operational experience that China cannot yet match. These submarines are the ultimate stealth platforms, able to control undersea domains and hold any target at risk. Beyond the frontline weapons, the capacity for industrial production and logistical support is a critical, often overlooked factor. Here, China's state-controlled industrial base provides a formidable advantage in scaling and speed. Its ability to rapidly iterate on missile designs and move them into mass production is a key concern for Western planners. The U.S., in contrast, relies on a more distributed and sometimes slower defense industrial base. While its system fosters groundbreaking innovation, it can face challenges in rapidly scaling production of key munitions during a crisis. This arsenal of democracy must be able to match the pace of a peer competitor in a protracted conflict. Finally, technology is only as good as the people and the networks that wield it. The U.S. military's greatest strength may be its investment in realistic, large-scale joint training exercises with allies around the globe. This fosters a high degree of readiness and interoperability. Furthermore, the Pentagon is all in on the concept of Joint All-Domain Command and Control, or JADC2. This is an ambitious effort to network every sensor and shooter, from a satellite in orbit to a soldier on the ground, into a single, cohesive web of information, allowing for faster and more effective decision-making than any adversary. So, who has the better military technology in 2025? The answer is nuanced and domain-specific. The United States retains a clear lead in foundational areas: stealth aircraft, advanced submarines, space-based assets, and high-end unmanned systems. China, however, leads in the operational deployment of hypersonics, the sheer speed of its missile development, and its capacity to scale AI systems and drone production. The final result? The U.S. still holds the overall technological advantage, but that advantage is more fragile than it has been in decades. China is closing the gap with breathtaking speed and strategic focus. The future battlefield will not be won by the technology of today, but by who can innovate, integrate, and deploy the technology of tomorrow faster over the next 5 years.